students also.
Okay.
So now all the faculty members from different reputed colleges and universities are here.
Okay.
So actually, we the teachers are always there. That is, we can't stop the education. So at
Mm-hmm.
any mode, offline or online, we must continue the learning process.
Yeah,
So
yeah,
welcome,
exactly.
sir.
Yeah.
So I already made you the co-host. You can share
Mhm.
your screen and you can start your session.
Yeah, yeah, fine. Yeah.
Okay.
So, like thing, like how what is IoT and IoT things, like all those things you guys were saying. Am I right? So now in today's session, okay, like directly I'm going into the session. Why? Because like I don't want to waste my time in introduction, all those things. Okay, for that reason, like directly I'm getting into the topic. So here, um, first I want to say you like a basic thing. Okay, like what all the things are very important in the IoT. Okay, that thing we'll try to understand. Okay, in the sense like will discuss about the IP address. So like each and every device, okay, which is connected to internet, okay, it will be having some IP address, some address should be there. So here in the IoT devices, like we will be using some Wi-Fi connectivity, or like we will be using some GSM, or like some other Ethernet. Okay, those kind of internet capability will be giving for the microcontroller. So you, for that device, there will be some IP address for that particular device. Am I right? So that is very essential for all IoT devices. Okay, so here I'm not sharing any screen here directly, like I'm saying a basic thing about this microcontroller. Okay, IoT microcontroller in the embedded embedded IoT devices, what all the things will be there. Okay, that we'll understand later. We'll get into the programming part. Okay, like in today's session, like what you guys will be learning is like how to assign an IP address to the microcontroller. Okay, there are different ways of assigning IP address to the microcontroller, and how the two microcontroller will communicate with each other. Okay, that also will try to understand. Okay, that also we'll try to understand in today's session. Okay, so here, just a second, I will share a screen. I hope in yesterday's session you guys got to know what is this IP address, how do we find out IP address. Like there are different classes, all those things we have taught you. So like once again, I will repeat the concept, like a basic thing. Okay, why? Because like according to this slide only, we'll be writing the program. Okay, that also will see like how to write the program. There will be some characteristics for the microcontroller. Okay, we'll try to understand that characteristics, all those things. So here, like you guys will be knowing what is this IP address. Okay, IP address, there are different version. IPv4 is there, IPv6 is there. So most commonly we will be using a IPv4. Okay, why? Because this is a 32-bit word length, and we were using almost like more than 20 years we were using this IPv4 only. So we are going for this IPv4. So nowadays, like IPv6 was introduced in the market. So IPv6 can be used for connectivity. For example, like in one network, okay, a lot of device should be connected. So in that case, like I need to go for this IPv6. Nowadays, like we are having a lot of internet devices, like what do you say, like mobile phones and remotes. Okay, some remotes and CCTV. A lot of devices are connected to the internet. So if all the devices connected to the internet, like addressing should be very large. Okay, addressing should be very large. So they bought this IPv6, but here we are having a IPv4. IPv4 is a very small compared to IPv6. Like IPv4 is very small. So addressing mode is very small, addressing is very small. So in this we can't connect a lot of devices. Okay, that is the disadvantage in this IPv4. So you can see here IPv4 addressing bit is like a 32 bit. Okay, in IPv6 like we'll be having 128-bit addressing mode, but here we are having only 32-bit. So addressing devices will be very less. Okay, that is what IP address. And so here you can see like they're given some example in the slide. Okay, like 32-bit address example they are given. So you can see here like 180. Okay, 180 is one octet. Another octet here we are having the second octet, the third octet, and fourth octet. Totally we are having a um, totally we are having a 4 octet. Okay, for one octet is nothing but a 8-bit. Okay, one octet is nothing but a 8-bit. Okay, if you calculate, okay, like a 8 into 4, like you will be getting a 32-bit. So totally 32-bit 32 devices, sorry, 2 power 32 devices can be addressed using this IPv4. So if we go for IPv6, like a 2 power 128, okay, 2 power 128 devices can be addressed. A lot of devices can be addressed. Okay, that is what. And here we are having a concept called net ID and host ID. Am I right? Yesterday in the session, like you guys understood this concept, I think. So I'm not explaining all those things. Like here we are having a class A, class B, like that. Okay, class A, class B, class C are most commonly used in the commercial activities, like in our homes and all, like in our home, in our college. Okay, in college, in the companies and all, like we'll be going for a class C. Most commonly we'll be going for the class C. And this class B also most commonly used in all the what do you say, like in industries. Okay, in the industries, like a big IT companies there, means in that company they will be using this class B. Okay, class B IP address they will be using. They will be not using this class A. Okay, in all the areas they will be not using this class A. Why? Because this class A are used to connect a lot of devices. For example, like I'm having one router. For one router I need to connect more than 10,000 devices I can able to connect. Okay, in a class A. But in a class B and class C, limited. Okay, there is a limitation in that. Okay, we'll see that also here. You can see in a class A. Okay, in a class A, the network, okay, network device can be, okay, 126 devices can be there. In 128 126 device. Okay, each device, under each device I can connect 16 16 million devices I can connect. Okay, under one device, like I can connect a 16 million device. Okay, that is what they are telling here. And next, here class B, like under one router or one Wi-Fi I can connect six 65 kilo devices can be connected. Okay, that is what. Okay, 65 kilo device, in the sense like a laptop, mobile phone, like that we can connect to a router. Okay, that is the difference. And here class C. Okay, class C is most commonly used, as I said. Why? Because you can see like under one router, like a maximum device is like a 254. Okay, maximum device is a 254. So in home, okay, in home, in college, okay, the maximum device will be like 50 devices. Okay, in home, in the sense like we can connect up to a 10 device. Okay, maybe like in my home, like I'm having a 2 laptop and one personal computer is there, and some other IoT devices are there. So if I calculate also, like I will be not having more than 10 device in my home. Okay, like an internet device. Okay, so here most commonly we'll be going for this one. For that reason, for limitation, we are going for this class C IP address. Yeah. So now here, you will be knowing the range. What is the range from class A? Class A starts from 1.0.0.1. Okay, that is the starting range, and ending range is 126.255.255.254. Okay, that is the maximum range. Okay, like what all the IP address falls under this. Okay, falls in between this range. Okay, that is called as a class A IP address. And class B IP address, you can see like 128 to 199. Okay, 191. Okay, that is the starting address range. Okay, ending address range is like 191. Okay, that is the ending address range, and the starting address range is like 128.0.0.0.1. Okay, that is the starting address range. So like if the IP address falls between these two range, okay, that is nothing but a class B. Okay, that is nothing but a class B. And here class C IP address will start from 192.0.0.1. Okay, that is the starting address, and ending address will be like 122.123.155.255.254. Okay, that is the ending IP address of the class C. Okay, in between this IP address, like whatever the IP address if you found, okay, that is nothing but a class C IP address. And so like if you observe here, okay, if you observe here, like you can see class C. Okay, class A IP address is getting ended with 126. Okay, is getting ended with 126, and class B IP address is starting from 128. Okay, starting from 128. So like there is one more IP address is missing here. 127 is missing. Okay, 127.0.0.0. Okay, that IP address is missing here. So 127 is called as a loopback IP address. Okay, 127 IP address is called as a loopback IP address, which is used in development. Okay, like if I am doing a web application or like some software application I'm doing means, so what I will be doing, like I will be making my laptop as a server and my laptop as a client. Am I right? Like I will be using a browser. Okay, that is the client, and my laptop like a hard disk. Okay, in the hard disk only, like I will be storing some images or some data I will be storing. So now if I want to test my application whether it is working fine or not, like that, if I want to test means, I will be going for 127 IP address. Using that I can check whether my software is trying to connect with the server or not, like that. I need to check means like 127 IP address is used in that case. Okay, clear. So here subnet mask. So here from here only, like we need to do a session, right? Okay, like what are the things I have given is like a brush up, like a basic thing about the IP address I have given. Okay, if I start talking about this IP address, like I can talk up to one day. Okay, till one day, like I can talk. Why? Because a lot of things are there in IP address. Okay, to understand in that IP address, a lot of things are there. So here we are having a subnet mask.
ಅವಳ ಮಗಳು ಇವಳು ಅವಳ ಹೆಸರೇನು ಗಾಯತ್ರಿ ವೈದ್ಯ.
So here we are having a subnet mask. Okay, subnet mask is used to differentiate. Okay, differentiate which is network ID. Okay, in in 32-bit. Okay, in the 32-bit IP address. Okay, which all the bits are belongs to a host ID and which all the bits are belongs to a network ID. Okay, if I want to find out, okay, if I want to differentiate what is the IP address, okay, what is the what do you say, like what is the which is the host ID and which is the device ID, like that, if I want to find out means, I need to go for this subnet mask. Okay, once again I will repeat. So if I want to find out, okay, there is a one IP address. Okay, in that IP address, like I want to find out which is the host ID and which is the network ID, like that I want to find out. So if I want to find out means, I need to go for this subnet mask concept. Using this I can split this host ID and the subnet mask. Okay, there is some calculation is there, like a logical calculation is there, that we'll try to understand. So why we need to do this subnet mask? Okay, like in the communication, in some internet communications, okay, we'll be sharing some files between a system to system. Okay, if I'm sharing a data between a system to system, like that, okay, in that case device, okay, the network should find out, okay, what is the destination address, like that we need to find out. For that reason, for that calculation, we are doing this subnet mask operation. So here you can see here like IP address class B. Okay, you can see like 191.100.120 sorry 250.72. Okay, that is the IP address of one device. Okay, now I want to differentiate, okay, which is net ID and which is host ID. So we know this is the class B IP address. We know this is the class B IP address. Now here I'm having some formula and I have found out, okay, this is the network ID and this is the host ID, like that. So here you can see like net ID will be filled by 255. Okay, 255 and 255. You can see like first octet and the second octet is filled by 255.255. That is nothing but a class B. And second two, okay, second two octet or a 0.0. Okay, we'll see how this calculation is done. Okay, so here you can see you guys know, you guys will be knowing like which is the host ID and which is the net ID. So here in a class A, the first octet is a net ID. You can see here W is the first octet, so W is the net ID, and host ID is nothing but XYZ. So XYZ, okay, that is the host ID. And in the class B, you can see like first two octet is the class B, and last two octet is the last two octet is a host ID, and first two octet of this class B IP address is like a net ID. Okay, that is what we are seeing here. In the same way for the class C also, first three octet is the net ID and last octet is the host ID. Okay, that is what we have seen. And see, according to the net ID, you can see the subnet mask. The first octet will be like a 255, which is net ID that will be filled by 255. Okay, that is what we are differentiating. Okay, that is how we will be differentiating, which is host ID and which is subnet, which is host ID and which is network ID, like that we'll be finding out. And next you can see here like a W and X. Okay, W and X. You can see W and X is nothing but the first two octet. Okay, the first two octet in this subnet mask, you can see like 255.255. That is what. And in the class C, you can see the first three octet will be 255. Why? Because like a first three octet or the network ID. For that reason, like here we are having 255.255.255.0. Last is the host ID. Okay, low host ID are differentiated using a 0. That is what. And next here. So here is the calculation. Okay, this is very important calculation. Using this only, like we will be finding out which is host ID and which is subnet mask. Okay, like exact calculation, how this computer will find out. All those things are done using this calculation only. Computer, the network ID, network device will be present in the computer, right? Okay, that device, okay, or that processor will find out which is network ID and which is host ID using this calculation. So here you can see we are having one IP address 171.100.255.72. Okay, that is what the IP address of one device, and they given the equivalent binary value near to this. Okay, equivalent binary value of this IP address they are given here. Okay, done. After that, we got to know this is the class B IP address. We know this is the class B IP address. So they given the subnet mask like 255.255.0.0 and 255 in the sense. Okay, 8 bit will be like a high state. Am I right? You can see here first octet. In the first octet, all the 8 bit is a high state, and in the second octet also we are having a 255. So all the bit will be high state, and last two octet are 0. That is what 0 they are given. Okay, now we need to do a calculation between this IP address and the subnet mask, like AND operation we need to do. We need to do a AND operation, logical AND operation. So if I do a calculation 1 with 1, So I will be having 1 here, 0 with 1. Okay, 0 with 1, 0 only will be having logical and operation, like according to the truth table. Like here we will be having a 0, and next here we are having a 1 and 1. So here we'll get 1. Like that, if we do a calculation, the first 2 octet data, okay, first 2 octet data will be remain same. Whatever we are having in the IP address data, right? Okay, the same thing will be present in the first 2 octet, and in the last 2 octet, according to the subnet mask, like here we are having a 0, here also we are having a 0. So if I do a 0 with any value, if I do a AND operation with 0, okay, 0 with any value, like that, if I do, like I will be having here 0, complete 0 I will be having here. In another 8-bit also, like I'm having a complete 0. So now we got to know last 2 octet, okay, last 2 octet is the host ID. Okay, last 2 octet is the host ID, like that we got to know. Okay, this is how we'll be calculating the subnet mask. So is this concept is clear? Is this concept is clear? Like shall I move for the programming part? If you are comfortable with this subnet mask only, I will be going for this programming. Why? Because like this is also very important in the IoT. Or like you are having any doubt? Okay, if you have any doubt, okay, you can get clarified.
In the host ID, we'll be giving the corresponding IP address. Like in this example, we have the host ID as 250.72.
Yeah.
Where we will give the corresponding binary here.
So binary in the sense like what you are talking.
The equivalent binary, because we are giving subnet mask now as 000 for this, right? For the host
So,
ID.
okay. I got your point. So here we are having a binary value, like we are having a 0.0 like that. We are having a binary value. So in the 0 place, like in the 0 octet of the subnet mask, whatever the data we are having, that we are considering it as a host ID. Clear? In the 0, like you can see here, 255.255.0.0 we are having. So here, whatever the 0.0 we are having, so whatever the data which is present in 0.0, so that data is the host ID. Like that, we are doing a differentiation. So differentiate. Okay, directly we can say this is the host ID and this is the subnet mask, like that. Okay, this is the this is the net ID and this is the host ID. Directly we can say, but system, how the system will calculate, okay, that we have understood here. So as human being, like easily we can find out. So where 0 is there, that is the host ID. Where 255 is there, that is the network ID. Like that we can differentiate. But system, there will be some calculation in the system, right? Okay, that is what this calculation. Clear? This is what your doubt, right? Is that is clear?
Yeah, thanks.
Okay. So in the next slide, we are having a TCP/IP protocol. Okay, like I hope you have seen in this slide itself, like how this protocol, okay, TCP/IP model data are transferred. In this slide only, you guys have understood, I think. So I'm not explaining this one. So in the yesterday session itself, we have explained. So here. In the like whatever the protocol we are using in the IoT, okay, whatever the protocol we are using in the internet, that is the TCP/IP protocol. So you might understood this OSI model. OSI model, in the sense, that is the theoretical model. OSI model is a theoretical model. So using that, okay, using that theoretical model, they created this practical model, that is TCP/IP model. So in all device, like in my mobile phone, in my laptop and all, like we will be using a TCP/IP model. Okay, if a device is connected to internet, means like that device will use a TCP/IP model. That is the practical model we are using. Okay, that is what the layer here.
ये देखो
So that
न्यूज़पेपर
is
लेके आता न्यूज़पेपर
sorry?
वो पढ़ा कोई भी उठा रहा है लिया जल्दी लेके आ अरे ये ऊपर पढ़ा न्यूज़पेपर ये देखिए जरा अरे ये देखो ये रही सूचना है और रुक जा यार डिस्क्लेमर the Tribune Trust does not take responsibility for the content of that बात करने देना वीडियो
Yeah, so we'll get into the programming. So here first I will show you, like in first phase. Okay, in the first phase, like we were using a TIVA microcontroller, right? Okay, in second phase also we'll use a TIVA microcontroller only. Like the TIVA microcontroller, whatever the TIVA microcontroller we are having, that doesn't have a Wi-Fi capability or like any other internet capability, doesn't have. So if I want to give a Wi-Fi capability, I need to connect an external Wi-Fi module. Okay, in some microcontroller you will be getting on chip. Okay, on chip you will be getting a Wi-Fi Wi-Fi or like a internet modem will be present in the single chip itself. But here we are having a separate microcontroller, and for internet connectivity we are having another microcontroller or microprocessor, a separate chip we are having. So we need to connect that chip here. So I will show you that chip, which chip we are going to use. Yeah, so you will be able to see the microcontroller here we are having, and in another and like I'm having a Wi-Fi module. This is the Wi-Fi module. The name of this Wi-Fi module is like a CC3100. Okay, CC3100. Okay, that is the name of this Wi-Fi module. So this is specially made for this TIVA microcontroller. So like here we are having a 20 pin and another 20 pin we are having here. So if I want to connect this modem, or like if I want to connect this module with this microcontroller, directly I can mount. Okay, like using this 40 pin I can directly mount, and I can use for my IoT operation. For my IoT project I can use it. Okay, this is how I will be using. Okay, just a second, I will connect. I will connect this booster pack. Okay, we'll actually like we'll be calling this module as a booster pack. Okay, in the TI term, like we'll call it as a booster pack. So I have connected that booster pack. You can see like I have connected that booster pack here. So now this microcontroller can be used for the IoT operation. Done. Now we'll get into the programming part. I hope like most of the people were present in this first phase. Okay, in the first phase training, we have seen the basic program, all those things we have understood, and now here we'll directly go into the programming. So in this training, like we will be using a energy or software. Yeah. So here, you will be able to see the program. Okay, like which software I'm going to use. Okay, that is the Energy software. Okay, in this platform only we will be doing. So this Energy software is similar to Arduino programming. If you are aware of this Arduino programming, directly you can easily understand this program. Or else, like if you have worked with this Energy software, you can also understand this programming. Why? Because both are same. 99% both software are same. That is what. So here in the very first line you can see like I have included, okay, I have included SPI header file. So why I'm including SPI header file in the sense like we are using a two board, okay, one is a TIVA microcontroller, another one is like a, CC3100 microcontroller. So these two boards should communicate. Okay, for that reason, like they are using a SPA protocol for communicating between these two boards. They are using a SPA protocol. For that reason, like I need to include SPA.h header file here. That is compulsory. And here Wi-Fi.h, okay, that file also I have included. Why? Because some APIs, okay, there are some special APIs for the Wi-Fi connectivity, like for Wi-Fi operation, like we are using some APIs. Okay, that APIs are present inside this Wi-Fi.h file. Okay, inside this Wi-Fi.h file we are having that file. So I have included that also here. And in the next line, okay, in the next line you can see like I have created a SSID variable. Okay, that is the array character variable I have created. Okay, inside this variable I have stored moto. Okay, moto is the Wi-Fi name. So microcontroller should know what is for which Wi-Fi I'm going to connect, like that microcontroller should know. For that reason, like here I have given like that. Okay, moto is the Wi-Fi name. I am giving the microcontroller. This is the Wi-Fi name. You should connect for the connect for this Wi-Fi router only, like that I'm saying. After that, if microcontroller knows Wi-Fi name, and the same way the microcontroller should know the password of the router, then only we can connect, right? In mobile phone, like what we will be doing, like if I want to connect to any Wi-Fi network, so first I will search. Or like if you are not searching, like you can give the name of the network. Okay, you can search the name of the Wi-Fi. After searching, like you will be giving the password of the network, right? Same way here, first I'm giving the name of the network and the password of the network. After that, okay, after that here you can see IP address. Okay, IP address is the data type. Okay, IP address is the data type. And next we are having IP. Okay, IP is the variable. So like in the C program, okay, in the C program, like we can have a custom data type, right? Okay, custom data type using a data structure. We can have a custom data type. Same way here, they created a custom data type, and the variable name is like a IP. Okay, in that we'll be storing the IP address later. When the device is connected, we'll be storing the IP address. After that, you can see in the wide setup, you will be able to see like I'm enabling a UART. Okay, I'm enabling the UART 0 along with the baud rate 9600 baud rate. So like if you are new to this phase, okay, if you are new to this phase, okay, you can interrupt. Okay, like I will explain from the basic. Or else like if you are able to understand this program, you can say me. Okay, directly I will go in my flow. So according to your wish, I can explain. So like shall I go in this flow only? Shall I go in this flow, or like should I change? Should I explain from the in-depth?
Please take it in depth.
I'm waiting for your reply. Just if you want to put a message in the chat box, you can put
Take it in depth.
okay. So in here